Hey, I wanted to do a quick overview of how to use our waveform viewer, surfer, and our test benches in conjunction to try and debug problems with our Verilog. So I'm going to focus on the load upper immediate test bench that's provided here. So first, quick overview of the test bench and what it's actually doing. So the test bench is going to create this test bench module. The test bench module itself contains a device under test. The device under test is basically a memory, an instruction memory, a data memory, an I/O device, and then your actual CPU model. And it will save all of the signals and information from this test bench module, so all of the signals it contains, and then everything contained in the modules within it, and with the modules within them, and so on and so forth. So this will contain a complete detailed history of everything that happens when we run this test bench. And basically what this test bench is going to do is it's just going to run several load upper immediates. That's the only instruction it runs, but it runs several variations of them. So the rom.txt file has the machine language representation and the symbolic representation of each of these. So it's trying to put A, B, C, D, E into the RA register 1, and then it tries to put FFFF into register 2, and so on and so forth. So this is just testing this instruction over and over and over with a variety of different values. It looks like it's got a total of 10 tests here. And then there should be some expected outputs. We'll check each of these registers to confirm that they contain that value. So I'm going to go ahead and run this test bench with the associated task for it. And I think we'll see down here in the terminal that it points out that it expected to get something, and it got a whole bunch of X's. That means it got some sort of uninitialized or unknown value. So we'll dig into that in just a second. So it looks like all 10 of those test cases failed. So we need to do some debugging. So when I go up here to the scopes thing, it shows that overall test bench module. And if I open that up, it shows that, first of all, if I click on it, it'll show all the variables, the signals directly defined in that module. But when I open the little disclosure button, it shows all of the modules it contains. So the device under test, that's actually defined in this particular test bench module. I could open up the top.sv just to back up. The test bench module declares this thing. The device under test is of type top, the topmost module. So I open the topmost module. The topmost module contains our processor module. Then it contains a module for the memory called imem. For the instruction memory, the data memory is dmem. And then our thing that represents our screen, IO. Basically what this waveform viewer is showing me is this whole hierarchy and then all of the internal variables and what they're doing over time. So I'm going to go back to that view. I really want to understand what's happening when I'm doing those load immediate instructions because clearly they're not working. So I'm going to go ahead and expand the device under test, and I really want to focus in on my CPU. This test bench isn't really doing anything with the data memory. I would like to know which instruction is being run. So I'm going to go ahead and click on the instruction variable down here, and it's showing me each of those test cases that it's going through in their assembly language format. Again, I could go back to the ROM file and kind of tie those two together. A, B, C, D, E, 0B7 is this first load upper immediate. And inside my trace here, there it is, the very first instruction being done. I think I'm also going to add in the clock signal here because it'll help me understand the timing of things. So initially, we're going through an initialization process, and the reset signal is asserted for a part of this time. I could add that in too. So we can see the reason we're stuck on that first instruction is because it's being reset. And once the reset is let go of, we go through that first instruction for a clock cycle. Okay, so I'd really like to understand why this instruction isn't working. I would expect it to, going back to my original thing, I'd expect it to put something in the RA register. So I need to understand what my inputs and outputs to my register are in order to understand what's going wrong. So I'm going to expand my processor model. If you remember, the processor module contained a control module and a data path module. I want to look at this data path module because I want to understand my registers. I'm trying to get this ABCDE stored in a register, and I'm trying to get it stored into a particular register. So I want to look at all the details associated with my registers. So let's see. If if I look through all my Verilog stuff, I think I'll find that the register file is this module called RF, register file. Oh, and now I can look at all the individual inputs and outputs to it. So I could look at A3, my input address, and see if that looks correct. Oh, I think that's okay. I think, so we're sending the number 1 in, and if we look up in our tables, we'll find out that the number 1 does correspond to the RA register. So it looks like I'm storing things, I'm trying to store things in the right place. What about the data? Is this A, B, C, D, E actually being sent in to be my writable data, write data? Let's add that trace in. Oh, looks pretty good. So I've picked where I want to store it and what I want to store. But something must be going wrong. So I guess the third part of storing things in a register would be actually specifying you want to store it using the write enable. And there I found my culprit. I was never actually asserting the write enable signal. So I had the what I wanted to store being sent to the right place, the where I wanted to store it being sent to the registers as well, but I was never actually doing the store it now sort of thing. I wasn't properly configuring my write enable. So now I would go back to my Verilog and kind of work backwards. I know what I'm missing. I need to figure out the right place to actually get it to do that write enable.